one and all. We will begin shortly, so I request everyone to take their seats and kindly settle down. It's a humble request to switch your mobile phones to silent mode to ensure a smooth session. I am Shriyasha Tari, a PhD student from the Department of Fibres and Textile Processing Technology, and I am glad to welcome you all to the 9th late Professor W.B. Achwal Endowment Oration organized by Institute of Chemical Technology. To mark the auspicious beginning of this event, I invite our esteemed dignitaries to come forward for the traditional lamp lighting ceremony. I request our head of department, Professor Ashok Atle, to escort our distinguished guests to the dais. Our esteemed speaker for the day, Honorable Vice Chancellor of Mumbai University, Professor Ravindra Kulkarni, In charge Vice Chancellor, Institute of Chemical Technology, Professor Ashwin Patwardhan, daughter and son of Professor Achwal, Professor Deepti Devbakar and Shri Abhijit Achwal. Thank you, esteemed dignitaries. Kindly take your seats on the dais. To invoke an atmosphere of wisdom and learning, we shall now play our Vidyapit Geet.
भवतु महन्मङ्गले
अभियन्ता तन्त्रज्ञकारिके शतप्रणाम भोस्तु जनायिके
नवक्षितिजे नवचेतनादे रसायन देविके श्रीरसायन देविके श्रीरसायन देविके श्रीरसायन देविके देविके
Now, I request our in-charge Vice Chancellor, Professor Ashwin Patwardhan, to present a floral bouquet to our chief guest, Professor Ravindra Kulkarni, as a token of our heartfelt gratitude. I now invite our head of department, Professor Ashok Atle, to extend his heartfelt welcome to the August gathering.
Namaste. Welcome to this late Professor Vaman Achwal Endowment Oration. And we are fortunate today to have the Honorable Vice Chancellor of Mumbai University, Professor Ravindra Kulkarni, as the orator for today's event. Thank you, sir, for accepting our invitation and taking out your valuable time and coming here to interact with the August audience. I am also fortunate and lucky student of late Professor Achwal, and I understand many of his disciples are present here. I studied under him when he was head of the department of the Textile Institute. So for the people who have come from industry, his introduction is not needed, but for the benefit of our students, I will briefly give a bio sketch of our late head of the department, Professor Achwal sir. Professor Achwal did his bachelor's BSc Tech in textile chemistry from this same institute in 1953, and then he went to continue his studies and did his doctorate from this institute in 1957. And during his BSc Tech, he was the first rank holder. After completing his PhD, he went to Germany on a DAAD fellowship, that is the German Academic Exchange Fellowship Program. And from the University of Aachen, he did his second PhD in 1960. And after that, he came back to the motherland, he came back to Bharat and joined this institute as a teacher, and then till his superannuation, he served this institute. And then he became professor of the textile and fiber science, and later on he became head of the textile department. I will just he has it's a long list of awards and achievements, but I will just highlight a few of them. He guided over 20 PhD students and over 60 master students, and more than 120 of his research publications got published, or research articles got published in the reputed journals of national and international repute. His research in cellulose modifications, solvents for cellulose, physicochemical studies in processing and staining techniques has been immensely useful to the industry. And he was consultant to many organizations in India and abroad. And he frequently used to travel to Germany, and he was fluent in German as well as Russian language. Other than, of course, the Indian languages like Marathi, Sanskrit, Hindi, and I understand he also was fluent in Gujarati. He used to speak Gujarati. And he was consultant to many organizations and many academic institutes. And he had a good command over many languages. And he was a member of the expert committee appointed by the Ministry of Textile to recommend measures to tackle the ban on azo dyes, and an expert evaluator for several eco audits. So Professor Achwal received the prestigious UDCT Distinguished Alumnus Award and Hari Om Ashram Award in 1987. And he was also awarded the gold medal of the Society of Dyers and Colorists, SDC UK. And apart from these technical studies and technical achievements, Professor Achwal took a keen interest in Marathi literature, drama and music. And he was a member of the committee to prepare the chemistry dictionary in Marathi. And he was also involved in preparing encyclopedia of textile industry in Marathi. Incidentally, yesterday was Marathi Rajbhasha Din, and just last week, probably you may have heard that the 98th Marathi Sahitya Sammelan, Jagatik Marathi Sahitya Sammelan was held in Delhi. And I understand Professor Achwal sir was also a national level bridge champion. So he was a very good bridge player. And his children donated rupees 20 lakh and initiated this annual endowment oration. Though through this oration, actually we are paying tribute to our late Guru, Professor Achwal. And we have also initiated few activities which I would just like to share with you. The textile department, the activities which we are doing, we are organizing the inter-university students competition. So on 4th of April, we are planning this inter-university student competition. So around 20 teams from many universities of this country are expected to participate. And after that, we are also organizing inter-institute conference. So many institutes in and around Mumbai are expected to present their research and advancements in the technology in those institutes. So that program we have planned on 5th of the April. And we have received sponsorship and donation from many of the industry partners. So already we have received funds from Rosary Biotech, Sarex, Britasel, Colortex, Ama Herbal, Montex Glass Fiber, Amtex, Pulcra, Nimkertech. And we are expecting some funds from some of the other institutes. And this indicates the bond which the institute has with the industry. And we have also received corporate social responsibility funds for some renovation of our laboratories. So Archroma has already provided us almost about rupees 1 crore for the lab renovation. We have also received some CSR funding from Pulcra and from Rosary Biotech. And we are fortunate to have this cohesive faculty where most of our team members have industrial experience. So this is another important thing. Most of the faculty members of our textile department have worked in the industry. And some of them have even done their postdoctoral research in some of the universities around the world. Some have done in China, some have worked in or done their postdoctoral research in Switzerland, in Germany, in UK, in the United States. So we have a mix of faculty which has industrial exposure as well as the academic research in many other institutes. So probably we understand or we can speak the language of the industry or the need and expectations of the industry. So what we expect is some projects or some kind of support from the industry where the faculty members can contribute. And we have also, and another very important thing is we have a very young and dynamic team. So don't look at me, excluding me. If you see the other members, the average age is around 45. So they have a long way to go. And another most important thing is our product. Our product is our students. And we have a very young, dynamic talent pool here. And what we expect or we request the partners or the representatives of the industry is please to give them chance for the in-plant training and placement opportunities, because they are the future of this institute and they are going to take this textile industry forward. So thanks for the and another very interesting thing is our second year BTech students have taken this initiative and then they have prepared or they have started working on preparing monthly or bi-monthly. Now we will start bi-monthly a magazine, Text Tweets. And I will request the representative of our second year student, Bini, to please come forward. And I will request the dignitaries on the dais to please unveil this magazine, text to it. The e-copy will circulate to you. So this is the first initiative which our students have taken.
Thank you, dignitaries. Now, to honor the legacy of late Professor W.B. Achwal, I invite his student and an eminent textile specialist, Shri Subhash Saudagar ji, to commemorate and share fond memories of Shri Bharat Pitare, the first student of Professor Achwal. Second. Sorry. So,
dignitaries on dais, Professor Achwal's family members, Professor Pitale's family members, friends and students. Just I'll give some glimpses of Bharat Bharchandra Pitale. He hails, originally he was hailing from a middle class family from Hindu colony only. He was with calm demeanor and very soft-spoken person. As far as academic qualifications is there, he was a second student of Professor Achwal for MSc Tech. He completed his BSc Tech in 1962 and got MSc Tech in 1965. His 1964 batch, he was a demonstrator. Some, T. Jivraj Jain, who was there, and he is in Arvind, he told me that he was our demonstrator. And he explained his quality, what just I have told you. He had done, Pitale had done his management from Jamnalal Bajaj. Career-wise, in India, he worked for Phoenix Mills, Morarji Mills, Century Mills in the beginning of his career. And latter part, for Hindustan and Ruby Mills, he worked as a head of the department that was in leadership position. He also worked in Indonesia for 4 years as a unit head. As far as quality of Bharat goes, he possessed many qualities like firm decision making, affable, and any dispute resolution, management as well as workers, unions, both felt that he was their man. Something, a contribution towards working towards the workers and management. The confidence is he was having that confidence. He was a teacher and he was a visiting faculty to Sasmira, UDCT and VJTI as well. Mr. Abu knows he was visiting here as a professor, correct? He had a strong value system. Former Professor Dinesh Rangnekar from this DICE department expressed that he was an exemplary, honest man. He was a family man and was teacher for his sons and grandparents. He left behind his wife and 2 sons. Elder son Salil is here and Rahul is here. Rahul works in Singapore, but incidentally he is here. Now I request that we should pray for his family, for this departed soul. I request Salil and Rahul to be at my side, so that, and we request everybody to stand for some time in order to pay the respect. Om Shanti. Thank you.
Thank you, sir. I now invite Professor Deepti Devbakkar, former Professor of Molecular Genetics, Head of Zoology and Director, Bioinformatics Center, and ISRO Chair Professor at the Pune University, and a consultant of Serum Institute of India, Pune, to say a few words about her father.
Good afternoon, good evening almost. Our distinguished guests on dais, Vice Chancellor of Mumbai University, and also, person whose home is ICT, I think. Then the Dean, Professor Patwardhan, Professor Athley, my brother, Abhijit Achwal. And I would also like to welcome every one of you, distinguished guests, many of my father's former associates or students, and current students from the ICT, and all the distinguished guests here. It is a privilege for me and a pleasure to be here amidst you for this very nice occasion of Professor Achwal Endowment Lecture today, which is the 9th lecture. And I would like to thank the Director of ICT and all faculty of Textile Chemistry, who has always given a very warm welcome to us and strived hard to make this function by inviting very distinguished guests as speakers. And I would like to place my deep appreciation for this. My father, when I think of him, a lot of memories come to me. Although his name was Vaman Achwal, by his friends and close family, he was called as Pandit, always, very fondly. And I think we know what Pandit means. And from his childhood, he got this name, Pandit. One of his important feature that I recollect was that he is very friendly. And I should tell you that this ICT or UDCT was really like a second home for him. In addition to studying here for his entire career, he spent 30 years here. But I think the friends he acquired during his education and associates and students became a part of our family for many, many years. In fact, a bunch of his friends, along with their families, continued to meet for over 50 years later, So just to show you, and I remember his students visiting our house, or every year there being a get-together. So in addition to his academic achievements, he had I would say he was very forthright, he was very passionate about his work, he was very disciplined. And I would also like to say one more feature, that his grandchildren were apples of his eyes, and today we have 2 of his grandchildren and visiting here in the audience. And of course, Nilima Achwal, my sister-in-law, is also here. And my sister, Swati Achwal, joins me and all our family. So what I'm speaking is on behalf of our family. My father, in his time as a scientist, did very many interesting things. But one feature comes to my mind, that one of his emphasis was on developing very user-friendly, rather expensive technologies, which were very eco-friendly, which made use of a lot of enzymes and advanced technologies at that time, and included fibers like, all the way from wool, cotton, silk, jute. In fact, he was an advisor for jute for the government of India. And when there was a ban on this azo dyes and many other dyes, he prepared a large number of documents and helped many industries in India as well as abroad and in Sweden. And I think he helped set up a few small industries and helped large industries. in how to overcome these problems by developing alternative user-friendly technologies and studied about natural dyes, and he developed a lot of processing technologies. I remember when I was studying biotechnology, he used to tell me that if you go to an industry, the person who is working there, it's no use telling him weigh in milligrams and micrograms. The technology, because you remember at that time when they were working, textiles was really a very, very important area, even financially. And my father was belonged to all these organizations very closely, like Atira, Sasmira, and all other organizations at that time. And also several, he had many international assignments, as was mentioned, in Russia and Germany. But what strikes me was, what we talk of environmental friendly, eco-friendly, he started it way ahead of time. And I think his students will probably remember, I was going through his papers and I found papers where there was use of fireproof fabric, or fabric which would be radiation resistant and things like that, just to name a few. My father, that is Professor Achwal, was, I can go on talking about him, and I think I'll just say a few more things and then stop. So one thing I would say is that when he went to Germany, he was one of the earliest Dutch scholars. He saw the world in West was so different than what was the situation here. And he ensured that my mother also visits with him. She worked in an industry, and both of them, tried to weave their lives by bringing in the best of the East and the West as they thought was appropriate. And were very modern, but still very traditional in their approach in some way. So I think with these few words, I will thank once again everyone present here, and I will again wish you all a warm welcome and thank you here. All the best.
Thank you, Dev Bakar ma'am. Now I request in charge Vice Chancellor to kindly deliver the welcome address.
Thank you, distinguished guests, Kulkarni sir, all the actual family members. It would be the third generation now that we met today, so it's very heartening to see such a close-knit family. And I think this is one of the traditions of ICT, that every department you go, you will find one or two lectures in honor of the in honor of the distinguished faculty members that the department has produced. And I think it's very good to continue that tradition, and this is the 9th lecture, so that's very nice. And on behalf of ICT, first of all, I would like to welcome all the Achwal family. Thank you, sir, for Kulkarni sir, for agreeing to give the lecture. And all the industry participants, all the past students. It is so nice to meet all the past students from the 70s when we were not born. They have passed out and they have been working in industry since then. It's tradition in many departments that alumni take so much interest in the day-to-day activities of the department, for the welfare of the department and for the welfare of the students. And our two one immediate past president and one current president of UA are here, and they are here practically every day. So Dr. Sani I meet every day almost, and so that kind of participation of alumni for the benefit of the institute and for the benefit of the students, it is very nice to see, and it is we are all thankful for that. And every time alumni has a alumni association gives us a helping hand in so many things. If you have time today, sirs, and other industry people, if you have time today, please go around our newly renovated classroom. H103 is there, and it is again an alumni initiative. So we are grateful to all the alumni for that, and we are grateful for all the nice teachers that have been there in the institute, which has made these alumni so great in their respective fields. So on behalf of the institute, once again, welcome, and please enjoy a thoroughly interesting lecture by Kulkarni sir. Thank you.
Thank you, sir. I request Dr. Kedar Kulkarni to introduce our eminent speaker for the evening, Honorable Vice Chancellor of Mumbai University, Professor Ravindra Kulkarni.
Good evening, everyone. It's a privilege to introduce today's eminent speaker, Professor Ravindra Kulkarni sir. He is holding around 32 years of experience in the field of chemical technology and is currently working as a Vice Chancellor of the University of Mumbai. Before joining as a Vice Chancellor, he served as Pro Vice Chancellor at the University of Mumbai, Head and Senior Professor at the Institute of Chemical Technology, Matunga, and Professor and Director at UICT, North Maharashtra University at Jalgaon. From the research point of view, he has around 18 PhD students, 2 PDF and 64 MTech students. He has almost 85 peer-reviewed publications with cumulative impact factor of around 210. He has 3 patents granted and 5 patents filed, 6 books chapters and numerous R&D projects including DST Sub, AICTE, RUSA, UGC. He has received several prestigious awards from the renowned institutes such as Professor J.G. Kane Memorial Award, UAICT Distinguished Alumnus Awards, Fellow of Maharashtra Academy and Science Award, and he is also elected Life Fellow of Indian Chemical Society. During his tenure as Pro Vice Chancellor and Vice Chancellor at University of Mumbai, University of Mumbai was bestowed with A++ grade with CGPA of 3.65 in the year 2021 by NAC committee and category 1 university status in 2023 by UGC, New Delhi. Professor Kulkarni was entrusted with responsibilities such as visitor nominee for faculty selection at IIT, many NITs and ISR. Chancellor nominee for selection, statutory officers in state universities, and expert on central and state government committees. He is also the convener for fatty acid FAD subgroup of oils, Bureau of Indian Standards. He has also served as chairman of the committee for the design of 4-year multidisciplinary degree and dual degree program in line with NEP 2020. Higher and Technical Education Department, Government of Maharashtra. Professor Kulkarni is working as a member of Maharashtra State NEP Implementation Committee for implementation of NEP. He is also a member of Council for the Inter-University for Astronomy and Astrophysics, NAC and Regional Institute of Education, Bhopal, FDP Syllabus Committee, Higher Education, Government of Maharashtra. So I welcome sir. Thank you very much.
Thank you, sir. It's now time for the much awaited oration. I request our esteemed chief guest, Professor Ravindra Kulkarni, to take the stage. I also request the dignitaries on the dais to occupy the front row seats of the auditorium.
Members from the Professor Achwal family, Professor Ditti Madam, his son, the in-charge Vice Chancellor of ICT, Professor Ashwin Patwardhan, Head of the Department of Textile, Professor Athale sir, other distinguished faculty, Head of the departments and the distinguished alumni of ICT who have gathered here just to pay rich tribute to Professor Achwal. In fact, when Professor Athale was telling in detail about Professor, one of the key points that I just thought of repeating again, that he, being a technocrat, he in fact involved himself even in writing text in Marathi, which exactly Professor Dipti Madam has also continued, because I have gone through many textbooks which Marathi text which she has written. So that's a really an important part, because when we are looking for implementation of national education policy with reference to pursuing technical details wherever possible through Indian languages. Okay, that definitely makes a really great sense. And before I could start my presentation, I just would like to something present about that, because that will be a rich tribute to Professor Sir, in a sense that like University of Mumbai is taking up writing of all technical books, science literature, specifically in 9 different languages. Mumbai is a cosmopolitan city, so we have every language faculty. We have professors, although belonging to the different disciplines, they will have different mother tongue. So we have just taken the benefit of that, and a specific text would have been written in around 9 languages, and which would be made available maybe within a short span of 3 to 6 months. So that's a big project that University of Mumbai is taking up. Marathi is, of course, at the heart of the process, but in addition to Marathi, like we would have 3 South Indian language, 2 North Indian languages, and then probably talking about the languages like Urdu also. So that makes availability including Gujarati, Sindhi as well. So that makes different text being available in 9 different languages, so that the basic idea is, of course, the medium of instruction will still remain in English, but whosoever would like to refer that technical literature in Indian languages, so the availability, we are just extending that availability to those who are really interested. Now coming back to the talk which I am supposed to present before you, let me extend my sincere thanks to Textile Department that they are giving me honor of delivering this talk in the memory of Professor. And probably, so I am coming from a different chemical technology background than the Textile Department. However, one of the key component of oils, oleochemicals and additives is connected to surfactant, which probably plays role in many other industries. And that's the reason why I would like to just present something about the developments that are connected with surfactant in specific reference to textile industries, while highlighting the right structure activity correlations which needs to be understood, so that the due understanding of usage of surfactant in a right mode could have been taken up, and that's how probably theme of my talk. Now moving ahead, what we observe that like overall the developments that are taking place all around is very fast, and naturally every industries are supposed to benefit from that angle. We are probably the fastest growing economy all across the world, and what we would see that when I'm looking at the fastest economy status, and then when a overall statistics connected to Indian growth in global context was taken up on 26th of January by Government of India, then we would understand that there are many growth-oriented phenomena that is likely to happen, which is really phenomenal. In a sense that we are a nation with largest startup ecosystem. Really, we are the one who would like to take up around the development in around 45 critical emerging areas out of total 64 critical emerging areas. So that's really one of the best, considering that when I'm talking about all those 64 critical emerging areas, 57 the China is leading, and only in 7 US is leading. And in that reference, when we look at our country, we are probably in the top 5 in in reference to 45 critical emerging areas, that appears to be a considerable growth. When I'm looking at specific reference to chemical technology, so we would see that, like if you either look at pharmacy, okay, we would say the overall growth rate could have been really high, and let us say like within just a period of 2024 to 2030, we would be able to move almost by double magnitude in pharmacy sector. And when I'm looking at textile, specifically within 10 years, we expect 10 times growth. So that's how current projection that we are looking at. FMCG industry, if you look at, there again we are finding out a very high growth rate of 14%. Now that makes, purposely these three industries have been included, rather other industries have not included, because I'm just connecting it to these three industries where the surfactant is supposed to contribute as a high performance chemical, as a specialty chemical, as a process performance additive. So in that angle, so the growth of these industries will naturally contribute to the growth of surfactant industry itself. Can I have this? So when I'm looking at the connected growth in surfactants, of course, even though we would say that, like in subsequent slides, we would see that surfactant is taking up development in almost every field in one or other form. But then it's all, being a surface active material, it is always used at a very minor percentage. So in spite of its use in different industries, we would say the surfactant growth within next 10 years would have been something to the region of 75 billion US dollar. And worldwide, there are of course leading industries, but one of the matter of happiness for all of us is that Galaxy is one of the leading industries in surfactant. In India, they are naturally leading, but probably they are exporting the surfactant related derivatives almost to 75 different countries. And surfactant requires lot of molecule development, surfactant requires lot of physical chemistry understanding, it requires lot of reaction engineering. So when you look at the combination of like an organic chemistry, physical chemistry at the same time, very good reaction engineering, then from that perspective, the development on sulfonation or sulfation or ethoxylation carried by Galaxy is definitely a noteworthy. And in that reference, like on global map, Galaxy surfactant, which is for which the main developer are ICT Aluminium only. So they have made us really a matter of say pride. And on global map of surfactant, Galaxy is leading in many ways. So traditionally, we normally talk about 4 categories of surfactant, but in recently, okay, that category needs to be looked at variety of the developments in the field of specialty surfactants, where we would say, like if it is a Gemini surfactant, it could be of different types, or it could be a combination of, like a Gemini surfactant could have a combination of non-ionic plus cationic, or let us say a non-ionic and anionic. So the kind of the kind of differentiation of surfactant on the basis of surface activity and the charge carried by the molecule, okay, so in terms of anionic or cationic, may not be relevant when we take up development of a large number of surfactant molecules, either under biosurfactant or let us say on polymeric surfactant or silicones. In fact, in case of silicones, many of the micellar behavior of the surfactant may not hold true. So that requires a lot of understanding. Now, probably as a surfactant technocrats, when we look at world around or industry around, then we do find that the surfactant finds applications in almost every field. Okay, so in previous slide, in fact, I have quoted one Nobel laureate saying that almost 90% of the development are connected with the surfactant. So the problem before surfactant development is that, like on one side, the molecule is highly complex. In fact, whenever we say something like sodium lauryl sulfate, ethoxylate, sulfosuccinate, okay, in reality, the structure is quite different and need to be understood properly, otherwise same surfactant with differing structure activity relationship may give different performances. So first point which we need to understand what kind of the structure that the surfactant carries. Second point of view, like there are many applications, that is what we would see. Like a same surfactant that is used as an emulsifier for emulsion polymerization, and the same surfactant that has been used as an emulsifier in textile processing, okay, may not hold any connect with one another, because the kind of surface activity that we are looking at, the kind of system that we are coming across is quite different. So that makes a problem really challenging. And probably the focus, of course, detergent is the principal part, but part of the detergent is also connected to textile in the sense that the fabric care segment connected to detergent is connected to textile only. And we do find that the focus probably in terms of surfactant development would have been textile, would have been in agrochemicals and surfactant, agrochemicals emulsions, and probably the surfactant development connected to electronic industries. So we would come across new developments on a continuous basis. Now, typically coming back to the textile sector, where we would like to use both words, oleochemical and surfactant, because many times they are used interchangeably. So in that reference, I have used both terminologies, because many times, for example, use of stearic acid or a calcium stearate for reducing melt viscosity during extrusion of fabric or during melt spinning of a fabric. In that sense, stearic acid may not have a right surface activity or may not have a kind of amphiphilic structure that we would be talking about. But then, the oleochemicals and surfactants are many times used interchangeably, and of course, on one side we have an hydrocarbon and other side we have a carboxylic group that provides a kind of a slight hydrophilicity in comparison with larger lipophilicity. So in that context, many oleochemicals are taken up as a surfactant, and that is the reason why the HLB number, okay, which was initially when presented by Griffin, was in the range of 1:0 to 20, but then it has been expanded now up to 40, just to count, just to include all those molecules which are being utilized as a surfactant. Now, we do find that under even an anionic surfactant, if you take the case, like on one side, the LABS, linear alkene sulfonate, could have presented itself as a role for detergency during scouring of wool, or maybe for a dispersion or emulsification for dye application. On the other hand, phosphate ester and another anionic surfactant would find altogether different role, like a corrosion inhibitor and a really best lubricant, typically from the point of view of hydrodynamic lubrication also. And when we look at the non-anionic surfactant, which would themselves on one side can work as a defoamer, on other side can work to provide a stable foam. Both of the possible applications by same non-anionic surfactant with changes in the structure activity relationship could have been made possible. And we do observe that particularly the role of cohesive agents as a providing a cohesive energy for fabrics. On the other hand, looking at lubricants which is providing a reduction in friction. So there we deal with two different kinds of the friction. One connected with fiber kind of a lubrication, so friction between two fabric fiber filament or element, or and the other, like while you are taking a fiber processing, fiber versus the machine parts, or fiber versus the bath liquor part. So in each case, the requirement of a lubrication would have been different. If you are processing at very high speed, it's naturally a hydrodynamic lubrication that we would be looking at, which would be provided by phosphate esters. And if you are looking for a initial fabric lubrication, which is probably forming the basis of either anti-static activity or as a fabric softening activity, we observe that there probably a cationic surfactant would have been a really a best example. So one comes across a different examples, and from that angle, it's really essential to understand the right connect with the structure and its connect with the activity development. Now, on one side, we are looking at applications of the surfactant in textile auxiliaries. Other part that we need to keep in mind, like in surfactant field, the technocrats have a habit of talking about like oral care surfactant, hair care surfactant, skin care surfactant. So, he just continued with that. The surfactant technocrats also talk about the word fabric care surfactant, which probably naturally a second part, like after manufacture of the fabric and when it's being put into use. So for taking up best care of that fabric, either in terms of removal of soil, providing a better fabric softening, retaining the dye intensity, providing a support to the fluorescent dyes. Okay, so that is also an additional phenomena which is connected to the altogether different sectors like fabric care. In a sense, like when we look at textile processing, right from the initial to final spinning, dyeing and printing, we would say that the surfactant and oleochemicals are really the workhorse chemicals for the entire textile processing, because we are looking for emulsification during scouring or dispersion activity. We are looking for corrosion inhibition. We are looking for altogether different activity like antimicrobial activity. Or we may be talking about the finish for the fabric in terms of the softening angle also. So, in a sense, it really appears to be workhorse of the textile processing. Now, there are definite expectations by the textile processes, and which the surfactant manufacturer must have to understand. Okay, in a sense that, because this has been an expectation by textile industries, and those who are undertaking surfactant development either in terms of molecule or in terms of manufacture or in terms of an application development must understand that the textile industries is now looking for very larger role. Say for example, like when we are looking for an environmental consideration, sustainability perspective. Now, we do understand the alkali treatment that is used in a textile uses very high temperature, high energy, high time, and generates a load of effluent. So where the enzymes are being taken up as a substitute, and we are talking about bio scouring. So in that case, whenever you are switching from an alkali to bio scouring, then a surfactant which was very well for alkaline scouring will not hold equally important or significant when I am looking at the bio scouring itself, because the kind of anionic surfactant that are used will not provide right stability considerations to enzyme. So we need to switch out to non-anionic surfactant in that sense. Some of the surfactants which were very well known are probably used on a very large scale. Alkyl phenol ethoxylates, for example, is known to be a very toxic. Its degradation products are also equally harmful, and so that's how we need to definitely give a way for replacement of that. Of course, now ethoxylates, fatty alcohol ethoxylates or fatty acid ethoxylates are definitely a surfactant which are very much of interest for textile industries, but in the long run also, we do understand that alcohol ethoxylates or fatty acid ethoxylates may not hold true in a longer sense of green context, because part of the molecule is coming from ethylene oxide, which is a fossil-based reagent. So, whenever we are marching towards a complete 5th or 6th generation green surfactant, probably ethoxylates may not be taken up as an important surfactant in that period. So, we will have to understand from that perspective. Then from the perspective like the stability of the surfactant, because you are using very high temperature during the processing, so we need to have a freedom from the smoke, we need to have a freedom from undue deposit, we need to have freedom from the possibility of degradation either introduced on the fabric or other processing system. So from that angle, a high level of stability for a surfactant indeed is essential. So from that angle, wherever like a, say for example, when I'm talking about a twin as a like sorbitol ethoxylates, then it could be based on oleate also, it could be based on stearate also. We would like to see that although oleate will have a better HLB, better performance, but from the perspective of the stability, oleate needs to be replaced by stearate also. So these are some of the concerns that we need to thought of. So like as we'll just look at these structures very quickly, like we do observe that there are plenty of examples of the anionic surfactant. The purpose in presenting this structure is of course different. It's not just that it is part of an information. The most important part, say for example, when I'm looking at the lower left, alpha olefin sulfonate. Now the name alpha olefin indicates that the double bond would have been in a terminal position, which is not the case. It's always an internal, one part. Second thing, we do observe that with alpha olefin sulfonate, we could have almost 30 to 40% of hydroxyalkane sulfonate. So a performance of an alpha olefin sulfonate would not be judged by the basic structure like alpha olefin, but would have been judged by a combination of internal olefin sulfonate plus hydroxyalkane sulfonate, which must be known. So whenever we ask for an alpha olefin sulfonate as a surfactant for, let us say, like emulsification processing, so in that case we need to ask for what is the composition, what is the relative ratio of internal olefin and like a hydroxyalkane sulfonate. The linear alkene benzene sulfonate, which is the workhorse, in fact we will take up that example where just a minor differences will lead to a lot of changes in the property. That is how we will take up that example also. Sulfosuccinate, for example, like if it is a diester, then it would have been utilized as a lubricant, as a wetting agent. Had it been a monoester sulfosuccinate, then it would have been used as a foamer. So different, same sulfosuccinate with differing structure will provide a different role. Cationic surfactant, probably I do understand that textile probably is one area where we observe all four categories of the surfactant being utilized with same importance. Otherwise, when I'm talking about skin care or oral care surfactant, anionic surfactant predominates. But here, cationic surfactant almost has a parallel role, primarily because you handle different kinds of the dyes, and that makes necessary requirement of use of cationic surfactants also. So cationic surfactants, again, by virtue of differing availability of hydrocarbon chain length and probably the kind of different ways of quaternization, and sometimes going for a polymeric cationic surfactant, which is on the top part, okay, where we would have a multiple repeating cationic functionalities, and wherever you come across a very tough task of suspension, tough task of, let us say, dispersion, in that case the polyquaternary compounds PQ6 to PQ72 could make themselves really good. Non-anionic is one area where a lot of structure activity for a same molecule could have been thought of. And like say, for example, if you look at the case of sucrose monoester, which sucrose has potential 8 hydroxyl group. So one, although described as sucrose monoester, it really is a mixture of mono, di and triester, and their relative proportions will make a larger difference in terms of HLB. So a larger mono will provide HLB close to 16, while a larger percentage of triester will provide an HLB close to 6 to 7. So on one side, one will work as a emulsifier for stabilization of oil in water, and the other exactly will work as a emulsifier for stabilization of, say, the water in oil emulsion. So the continuous system hood. The EOPO kind of a block system, okay, that has now presented a very larger variety in terms of the system, and particularly when I'm talking about a right magnitude of the fabric softening, when I'm talking about a kind of a softening connected with larger degree of lubrication also, then EOPO kind of a combination, ethylene oxide, ethoxylate, propoxylate kind of a combination could really play a good role. Now, taking up a few examples where we would like to take up the clear understanding whenever you are putting surfactant in actual use, either for a textile applications as an auxiliary or a fabric care material, either way. So we'll take a few examples okay, where like the surface activity as a function of structure has been assessed, and the results of those assessment are presented before you. Now, particularly in terms of a textile fabric, when I'm looking at, so we do observe that the synthetic fabrics, starting from polyester or let us say polyfluorocarbon or polypropylene, okay, what we understand that they really make larger angle of contact with water. That makes spreading with water very difficult. So as a result, with polyfluorocarbon, for example, a very large degree of contact. Now, when the angle of contact is more than 90, so naturally it implies that spreading is almost a impossible task. So we need a surfactant which will be able to provide reduction in the surface tension of water from 72 to 19. So that is a tough task, and only silicones and fluorinated surfactant can facilitate that. So that's how everything, only thing, whenever we are looking at interpretation of surfactant in textile processing, okay, we need to understand that it's primarily because of interfacial effect and nothing else. It's primarily so the way the surfactant is acting at a fiber-fiber interface, the way the surfactant is acting at a fiber machine part interface, or way it is acting with fiber with the solution that has been taken up at different stages of processing. So the real interfacial interactions across those two interfaces will make a deep impact. And so from that angle, okay, we would say even like a normal role for a surfactant is to reduce surface tension. But that may not be sufficient for solubilization of a, let us say for example, for a dye. You need micellar systems to be established, then and then only solubilization would be possible. For a general purpose emulsification, a normal surface tension reduction could be a real possibility. Now, whenever you are looking for a use of oleochemicals as a viscosity controlling agents or as a viscosity modifying agents, okay, we would observe that we have a larger choice, okay, because when textile processing is carried, okay, we have three kinds of the like a frictions that we come across, primarily three, overall five. So we would be talking about a boundary lubrication or boundary friction. We are talking about an hydrodynamic friction or hydrodynamic lubrication when the system is working at very high speed, and then when you have a solid to solid, that would have been another. So from that angle, the different viscosity, like different oleochemicals with different magnitudes of the viscosity first, and different magnitudes of the viscosity index. Okay, that is what would have been very much essential to take it forward. And say most of the fabrics are carrying negative charge, and as a result, whenever I am looking for a fabric softening or whenever I am looking for a anti-static activity, cationic naturally takes up a lead role in comparison to anionic surfactants. Now, taking up examples one by one. Now, the LABS, linear alkyl benzyl sulfonate, one of the the very lowest cost surfactant, a second generation surfactant, is being made available in every sector, right from the detergent to the agrochemicals itself, or polymers, plastics, or even in the area of ore flotation chemical. But when you are using linear alkene benzyl sulfonate, okay, so we understand that it's a Friedel-Crafts alkylation followed by sulfonation, and the attachment of an aromatic group across the hydrocarbon structure, okay, could make a large impact. Now, you start with, as is being shown, we start with an olefins obtained by dehydrogenation of paraffins. Even if you start with olefins with high degree of purity, let us say like you have started with C12 olefins and you have purified, isolated with an olefin, let us say having a double bond exactly in the center, 6-7 position for a C12 for example. Even then, it is an observation that whenever you are taking a Friedel-Crafts alkylation, okay, it's always an isomerization, and almost 50 to 100 different isomers do exist. And there, again broadly, whether the attachment occurs at central place or whether the attachment occurs at terminal place, that will make a huge difference. And say broadly, the surfactant processes define them as L2P, that is low 2-diphenyl content, okay, that's, which is made possible through use of catalysts like hydrofluoric acid, or H2P, okay, which is made possible by acidic zeolites or AlCl3 catalyst. Okay, so so you would have a differences in the overall structure, like in terms of benzene attachment to an hydrocarbon para sulfonation. Okay, that holds true. But then you would find one catalytic process providing 2-phenyl content almost to the level of 30%, and second to the level of 16 to 70%. So not a much difference, but that is going to make a long-term impact on a surfactant when I'm looking at its use. Now, naturally, when I'm looking at a surfactant, let us say for different stages of textile processing, what would have been the main angle? Say what would have been the surface activity, which is governed by molecular weight. What would have been the solubility considerations? Okay, whether it's a easily getting dissolved or it is sparingly soluble, or requires a, if it is sparingly soluble, whether a solvent or hydrotrope addition is required. Okay, so that may be another consideration. And then connected part, whether it's connected to foaming, hard water tolerance, because you are using a large bath liquor which may not carry soft water. So there we do observe that the 2-phenyl content, okay, with zeolite and AlCl3 is close to 25 to 30%, while that for HF alkylation would have been in the range of 15 to 17%. Now, what would have been its impact? Just a close understanding, when I am looking at a fabric care formulations, okay, when I am looking for a fabric care formulation, typically as a liquid detergent. Now, when I am looking at a liquid detergent based on LABS as a formulation, one of the key requirements for a fabric care liquid detergent would have been it should remain or maintain clarity throughout its shelf life. Okay, that would have been the important requirement. Now, look at the two different products. Everything is same, feedstock is same, the only difference was catalyst, and different manufacturers for LAB take up different role for catalyst. So, the upper curve, so like it's a graph of cloud point versus percentage active of a linear alkene benzyl sulfonate in a liquid detergent which is formulated as a fabric care formulation. Look at like the lower dotted curve represents the formulation based on LABS, which is manufactured through zeolite, acidic zeolite process, and the upper one, which with a solid curve, okay, would have been based on HF catalyst process. HF catalyst is known to have low 2-phenyl content. Now, because of low 2-phenyl content, the solubility behavior drastically changes. Everything is same, drastically. It's a difference of only 18 to 25%, not much. But then, if you look at as the percentage active increases, as you start adding more and more surfactant from the perspective of performance, we do understand that the fabric care liquid detergent formulation based on the like a Dettol based linear alkylene sulfonate can maintain clarity of the liquid detergent even at 25% active, well below 0 degree centigrade. Okay, so that's the point. On the other hand, we observe that for a normal HF catalyst systems, okay, the cloud point almost goes to the level of 15 degrees centigrade, which means like you need to add solvents. Now, when you are adding solvent, which are normally hydrotropes, are very expensive, that alters your like viscosity consideration, that alters your surface activity consideration. Okay, that's the point. Now, if you connect it to the molecular weight further, if you connect with this molecular weight, because we had talked about only attachment. Now, when I'm talking about the hydrocarbon number, okay, which is started with olefin and which rarely has only C12, it could be a broader distribution from C10 to C13, sometimes C14. A difference of average carbon number just of 11.6 and 11.3, because I've just taken these two numbers because these are the products available in the market with 11.6 and 11.3. Now, when I'm going for a average carbon number for 11.6 with same 2 phenyl content, rest of the things being similar, okay, whether whatever the additives that you have used in the liquid detergent formulation, okay, so with all factors remaining same, we find that a LABS with 11.6 will provide reduction in the solubility, will provide reduction in the foam volume, will provide reduction in the hard water tolerance. On the other hand, the one with 11.3, matter of 0.3 only, will provide a higher solubility, better foam, but lower viscosity and lower surface activity. Normally, molecular weight and surface activity go hand in hand. So that's a difference that we would talk about. Alcohol sulfates or alcohol ether sulfates. Okay, the one very well-known surfactant, a representative of third generation surfactant, which was being introduced as a very milder as compared to LABS. But now, really, we had such a series of surfactant where even SLS appears to be an irritating material. So, because one of the parameters, if you would observe, like non-irritating, non-toxic, non-carcinogenic, okay, are the parameters. And sulfonates and sulfates over the globe are taking up either some bad name in one or other context. It's not because of the structure. It's not primarily because of the structure. It's primarily because of the level of impurities which they carry. Say, for example, linear alkylene sulfonate will have a sulfone, okay, which needs to be managed well below 50 ppm. With alcohol ether sulfate, okay, 1,4-dioxane would have been a possible impurity if it just increases by from 20 ppm to 100 ppm. Okay. If the load of 1,4-dioxane increases from 20 to 100 ppm, okay, not much, the entire surfactant color will change, and of course it will be unsafe to handle also. So these two surfactants, okay, now normally say all alcohol sulfates are referred as an SLS. It's a common trend. Okay, they use alcohol sulfate for sodium lauryl sulfate for all kinds of an alcohol sulfate. Although even though the carbon number may not be the same. Okay, the lauryl indicates the carbon number has to be 12. Now, if you look at this structure, okay, it's like the overall analysis which was carried out, okay, in terms of foam stability analysis for different carbon composition of SLS. So we observe that as you move from a pure lauryl part, C12, sodium lauryl sulfate, and as you just next addition is 14. Now, so the source of lauric is coconut and palm kernel oil mainly. And if you start taking up directly fatty alcohols from coconut oil, then it will have 12, 14 together. If you wish to make 12 rich, then you need to carry distillation. So with a normal C12, C14 range, which coconut or palm kernel oil has, okay, you would find just switching over from a C12 pure lauryl alcohol sulfate, jumping to the C12 to 14, okay, will provide a drastic foam reduction. So wherever you require a stable foam bath, switch over from a sodium lauryl sulfate. If you would have used in previous batch a SLS based on C12, and if in next batch, like if you would have taken C12, C14, you would find almost a drastic difference. And if you move on like C12 to C18, which is normally based on hydrogenated fat, okay, you will find a completely drop in the foam wall. Although SLS is known to be the foamer material, okay, but if it has C16, C18, then it will provide a drastic change. Now, connected with this alcohol sulfate, because now with alcohol sulfate, okay, one of the key drawback that has been observed is probably it has a not very low craft temperature. Okay, it doesn't have, like, so whenever you like to work on a formulation at low temperature, okay, then the SLS may not provide an appropriate solubility. So from that perspective, the lauryl alcohol was ethoxylated to an extent, to the level of adding 2 to 3 moles of ethylene oxide, and then sulfated, which provides a infinite degree of solubility, which provides a very good hard water tolerance, which provides a very good stability against electrolytes. So SLES would provide a very great advantage as against SLS. However, SLES will require lot of preservatives. The moment you switch over to SLES, in comparison to SLS, the SLES will not be stable if you don't add enough of preservatives. It will take up biodegradation very fast. So comparatively, when I'm looking at SLES, okay, so a difference from 12 to 14 to 12 to 16, okay, with same number of degrees of ethoxylation. Okay, in comparison to left chart, SLES provides a moderate difference only, not very large. So you may not find a large difference between C12, C14 plus 2 as against C12, C16 plus 2 itself. So SLES provides a little better advantage with both SLS or SLES. Okay, we need to keep in mind that, or in fact in many of the surfactants, okay, you need to examine the concentration solubility relationships. So it's an observation that at lower concentrations, say like below 30% and 70% water or like more, and the other way, like a very high purity, let us say like 90% surfactant and 10% water. On either side of the range, very low concentration or very high concentration, you would find SLS or SLES or other surfactant to be like providing a dilute solutions, low viscosity, away from paste or rubber-like conditions. But the moment you start moving from 30% onwards or 40% point of onwards, one which was appeared to be very thin in terms of consistency, at 50%, the same system appears to be rubbery-like. And on the other hand, above 80% or 90%, it is again a thin liquid. So that kind of a handling part we will have to keep in mind while taking up the SLS or SLES or other anionic surfactants as well. And say one can, so if you don't want to move towards SLES because of preservation drawback, then SLS solubility can also be altered. Okay, so one of the rule is that, like, instead of going for a long chain alcohol, okay, which is naturally based on coconut or palm kernel, let us take up an alcohol based on, let us say, like an oxo process, oxo hydroformylation process. The fatty alcohol manufactured through oxo hydroformylation process will give you a larger branching, and a branching introduces more solubility. So same SLS with a larger branching can have craft temperature reduced from 22 to 10 degrees centigrade, meaning thereby you can extend the benefit of very largest solubility above craft temperature, very easily available above 10 degrees centigrade in comparison to 22 itself. Now going with non-anionic surfactant again. So the purpose in providing all these illustrations is primarily to look at the requirement of understanding of handling surfactants, where structure and activity is highly correlated, and that understanding is really important. Now let us talk about this alcohol ethoxylate, plain alcohol ethoxylates. Now ethoxylation is probably a statistical process, and as a result, degree of ethoxylation always gives a broad number, and we always refer it by an average ethylene oxide content. So 2, 4, 6, 8, likewise. So if you just change, let us say if an alcohol ethoxylates has a degree of ethoxylation say around 4, average 4, then the HLB would have been around 6.5, meaning thereby it can work in an oil system, okay, oil as a continuous system, or a emulsion stabilization for water in oil. And just moving from the degree of ethoxylation, say let us say from 4 to 10, okay, say roughly 9 or 10, okay, you would find same HLB now changed to the level of 13.5 up to 15. So providing a role for solubilization. So that much differences in the system. Now from the point of view of the fabric care systems, so we need to know the right degree of ethoxylation for utilization of alcohol ethoxylates in different textile auxiliary formulations. So one observes that from whenever you would like to use alcohol ethoxylates as a wetting agents, as a someone who would like to promote spreading, okay, then in that case one observes that we would have a right average degree of ethoxylation close to 6. Okay, that will provide a best wetting effect. Okay, so the minimum of the curve that is connected to 6. And say like if you are using alcohol ethoxylate as a replacement for LABS, primarily to control foam, okay, because non-anics are primarily chosen for foam control also, in addition to the various role which they are playing. Say for example, if I am looking for a fabric care formulation for a front loading machine rather than top loading machine, okay, then a front loading machine, washing machine has a has a requirement that the foam should be absent completely. So you may require a low foam system. So in that case, like we need to think of like the foam volume correlation with degree of ethoxylation also. Now keep in mind, purposely two different temperatures analysis at two different temperatures are presented before you, because when you are looking for a cotton, you are going for a very higher temperature. So unlike the role for anionic surfactant, non-anionic surfactant represents inverted temperature solubility, and from that point of view you would find that when I am looking for same degree of ethoxylation, say let us say 6, so the alcohol ethoxylate at 20 degrees centigrade will provide a very high foam in comparison to one at 60 degrees centigrade, because it's primarily because of inverted solid. So this relationship must be kept in mind. And of course, on an average, if you are going for a larger degree of ethoxylation, 8 to 9, then we need to understand that it is applicable only in those applications where a foam volume of the order of 150 to 250 ml could have been tolerated. So that's the basis for an application. When we look at differences between cotton and polyester, in reference to alcohol ethoxylates, okay, we would see that for a polyester, which where we are talking about detergency at 30 degrees centigrade, a degree of ethoxylation providing the best level of detergency would have been around 6, while that for cotton would have been around 7. Okay, so that difference will have to be kept in mind. Now, looking at this particular range, okay, so looking at the ethylene oxide or propylene oxide block copolymer system, which is providing a larger varieties in terms of formulation development, okay, where you are not looking for a source of like an hydrophobe specifically from hydrocarbon. Okay, that was the case in all earlier example that we have taken up. Here, the role of hydrophobe is taken up by propoxylate component, and the role of hydrophilic component is being taken up by the ethylene oxide condensates. And the way you combine them and the way you introduce the kind of initiators, okay, you would be in a position to take up EO, PO, EO, meaning thereby ethylene oxides ethoxylate system on a terminal part and propylene oxide on a core part. On the other hand, okay, going with a let us say a choice of a different initiator, then you could have propylene oxide as a terminal block and EO as a central block. The properties will drastically change from all perspectives of fabric softening, emulsification, lubrication. They are probably providing the best lubrication. So in fact, now wherever you are looking for a high temperature stable lubrication, okay, then these EO-PO blocks are the best, and they are replacing many fatty esters in that reference itself. Now coming to the next rule, okay, just like in anionic we have seen generations. In cationics also, okay, we do find development in terms of cationic surfactant from differing structure activity relationship. Now this particular reference of going for generation to generation comes from different perspective. One, because cationics we are looking for an antimicrobial activity whenever you are looking for fungistatic property or likewise, or when we are looking for a like fabric softening activity, and we are looking for biodegradability, and at the same time we are looking for a non-toxicity also. So the first generation, okay, so if you start with, okay, that was a simpler structure, okay, where we have a primarily alkyl dimethyl benzyl quaternary ammonium chloride or bromide, whatever you would say. Okay, that provided a normal way of a antimicrobial activity or the kind of a like hair care or fabric care kind of a activity. But then the benzene, like in those days, like you need a powerful antimicrobial activity. Slowly, the microorganisms develop resistance against the antimicrobial active agent that you are using. So when the first generation surfactant, cationic surfactant could not put into use and could not provide a kind of activity efficiency that you are looking for, then like the benzenes, you would find a lot of substituent being incorporated on benzene side, particularly on halogen attachment, which increased the antimicrobial activity. But then when you moved to the third generation, okay, the toxicity associated with aryl and substituent, okay, is not an acceptable. So we thought of looking for getting rid of aromatic structure simply. So the third generation primarily talks about a complete freedom from the aromatic system. But then the activity either in terms of fabric softening or let us say antimicrobial naturally will come down. So to begin with, it was combined with the first generation or second generation surfactant to get an optimization between biodegradability, non-toxicity and the antimicrobial activity. Then we moved ahead from the cationic surfactant where we are going for Gemini surfactants. So a twin chain system. Okay, so the same molecular structure repeated twice through a spacer attachment, providing a Gemini surfactant where you would have completely alkyl groups only. But now, since the surfactant is repeated twice, okay, in a sense twin structure, the antimicrobial activity has been doubled. Okay, so that's how the subsequent part. And then we are looking, so in fifth generation, the synergistic combination of different Gemini surfactants were thought of. Currently, polymeric cationic surfactant, PQ6, the one example which we have come across, PQ7 or likewise, okay, they are the powerful antimicrobial agent. And in the current context, we are taking a polymeric surfactant in combination with Gemini or let us say dialkyl dimethyl benzyl ammonium chloride itself. So a combination of like moving, so that period of hardly 25 to 30 years only, not more, presents lot of development on a cationic surfactant moving ahead. Taking up a specific development on a fabric softener, specifically. Now, like normal mechanism that is being always talked about for a fabric softener, like a temporary fabric softening, of course, where we expect the cationic fabric softener being cationic will get adsorbed on a negative charge, provides a lubrication and moisturizing property, and as a result of that, you will find the smoothness of the fabric itself. And this particular structure, dihydrogenated tallow, okay, dimethyl ammonium chloride, okay, so that was really popular, and then moved ahead. Now, see, the structure as such is based on a straight chain only, based on a straight chain only. So, even we are not talking about any aryl group, but even then, one observes that even with this system, the biodegradability that we would be expected to get, because these are temporary fabric softeners, so would move out with every fabric washing cycle, and it would go to effluent. And say even then, it was observed that this was not getting degraded properly, and it provided months almost for biodegradation. So this was required to be replaced. Now, just look at the next slide, example, which was subsequently developed in terms of fabric softener. Nothing much was changed. The only thing, see here, the hydrocarbon, like the hydrophobe is directly attached to the positively charged cationic nitrogen moiety. Now, same, when I am talking about, rather than starting with plain hydrocarbon, let us introduce the replacement of hydrocarbon by a fatty system, fatty ester system. So now you have everything similar. The long hydrocarbon chain which was there is now replaced by fatty ester molecule connected with the diethanolamine or monoethanolamine likewise. Now with this, okay, we observe that the biodegradation becomes really quick, and soon it started replacing everywhere. Now, going with this kind of a ester quat, or those based on fatty ester methyl ester, there are multiple benefits that have been thought. One, okay, it is very synergistic with cationic modified natural clays, or cationic modified natural polymers, say for example cationic hydroxyethyl cellulose. If it is combined with this fabric softener, ester quat, then observation is that you require almost 50% of the fabric softener requirement, which otherwise would have been required when used alone. Okay, that's the advantage, and that naturally reduces our load on subsequent effluent issues also. So, of course, still it has to be kept in mind, it's not a very permanent fabric softener. Okay, whenever you require a permanent fabric softening, it has to be a reactive system. Now, probably I will just stop here. Okay, so before like summing up, okay, the different examples, okay, I would like to bring on just few developments that are likely to come up, particularly from the perspective of the surfactant as a for a textile industry. Okay, so the two different developments, rather three developments that are likely to become prominent in near future. Okay, one connected with the role of surfactant as a catalyst rather than as an additive. Okay, a different role, which will work as a good catalyst for treatment of textile waste, and is known to provide a hydrochar of very high calorific value. Okay, that's one of the one experimentally proven evidences that has come into fore. And now naturally when as I said, like if it is proved with one particular surfactant, Okay, we need to see that it has to be established with correct structure activity. Okay, so that one aspect which is now being under investigation. Second, probably phase change material. Okay, where oleochemicals will play more role rather than surfactant, because these oleochemicals have a higher latent heat and which can take up the heat easily from the fabric or would give it back either way. Known to have very high latent. So we understand that if like say for example the fabric which is supposed to be taken up particularly for winter support or like the other way around with reference summer the other way. So a phase change material providing a higher thermal changes either on lower side or on higher side will provide fabric with very good thermal effects also. And the third part, okay, so we are well aware with lotus effect and lotus effect normally talks about very high degree of hydrophobicity, but here in addition to hydrophobicity which is working as a strong say the water repellent characteristics, we could have a 100% hydrophilicity, a very super hydrophilicity, okay, where it would provide a very modification of the surface in terms of an hydrophilization behavior. So we expect the developments to be carried forward in near future, which will provide newer applications at least in the range of surfactant. I extend my sincere thanks to the audience for patient listening. I hope I have completed within the due time, and I'm happy to take up few questions.
Excellent presentation. You have mentioned the everything from genesis of the surfactant to the application of the surfactant. No, I'm biologist. That you have mentioned the ocean of the surfactant, types of the surfactant. What is your opinion or think about the biosurfactant? Biosurfactant. The question is around the biosurfactant, or that we understand the large scale production and the cost. But at the same time, one should consider their toxicity problem, the biodegradability, and the environmental friendly. So if you compare the two aspects in the reference to the science and technology and overall the performance. This is the first part, sir. What I have a number of the time that you have mentioned, the surfactant also having the basically problem, that is a basically microbial resistance. Now, a small molecule having basically disadvantages. Microbes are smart microbes. They develop a resistance. But if you see the biosurfactant, it does not allow the organism to be resistant because of the efflux pump. So this is my first part. Sir, as a biologist, I'm curiosity of your depth that you have mentioned. What is the perspective at the artificial intelligence age? The perspective of the double bond, the ester bond, ionic loads, and side chain to design the future surfactant.
Thing you can point out. The slide on biosurfactant was eliminated. In fact, it's there in the formulation, but just for the sake of system. Biosurfactants are definitely an emerging field. As you yourself have pointed out, the scale of production is very low, and as a result, the cost is really going up. So, for example, Godrej has manufactured sophorolipids, and they have traded it as a biogod name. Bio stands for biological survey, and God stands for not for God, for Godrej. The overall observation, say, here again, the different perspectives which I have presented from the structural perspective, same thing is applicable to biosurfactant also. And as long as you don't understand that, then it is likely to create an issue. Unlike regular surfactants, okay, chemically derived surfactants, biosurfactant presents a lot of structure dependence on pH. Okay, so lipids, for example, if you move towards acidic and if you look at an alkaline pH, totally two different structures emerge, and application naturally has to be thought of. So whenever you are looking for, the first part that we'll have to keep in mind, that with biosurfactant, the establishment of applications with reference structure is very essential, first. Second thing, it is still lacking reproducibility, because we do not, there are multiple variables. Now, as far as surfactant manufacture is concerned, like because of very good development in the reaction engineering, we are now talking about a very precision purity, at very ppb level also. That kind is possible with a thin film sulfonation reactor systems, or the different reactor systems that are available under ethoxylation. So the technology for reactors for manufacture of the surfactant is well mature, and its connect with the structure reproducibility is now well established. So we would be able to give a clear thought on. With biosurfactant, unfortunately, this particular process development is still have to go a long way. Second part, the kind of load that you generate after manufacturing a biosurfactant in comparison to the manufacture of regular surfactant is huge. Okay. The biosurfactant being biologically derived, okay, now we naturally consider it to be an eco-friendly. But then post downstream operations or pre-stream operations, okay, presents a lot of challenge, which we'll have to think about. Because the moment you scale up, then talking about the effluent load will have to be answered properly. Okay, that's the another part. Third part, now, of course, worldwide. Okay, so I just skip the last slide, because where all the surfactant manufacturing CEOs, they have just expressed opinion over a period, and I have just added them. So many of them are looking for biosurfactant naturally as a one particular product development, because that will provide a green tag to them. Currently, many of the surfactants, because consumer also looking for, say for example in US, there has been a trend that we don't want sulfates and sulfonates. It's a trend. So when consumer is looking for such trend, we need to have a green. So many manufacturers are taking up from that angle. I hope I have covered.
Sir, thank you very much for your nice presentation. Sir, in your second slide that I have seen that you have mentioned the oleochemical and surfactant as textile auxiliary. They are one of the item is desizing agents. So can you please give one example that which surfactant act as a desizing agent?
So particularly, we are mainly talking about anionic surfactants. Inherent in sulfate, sodium chloride, sulfate, and sodium chloride are the one which are combined with between 60 or 280, so as to provide a right level of diversification during the of the sizing.
Sir, just by 2020 or combination with this anionic and 2020?
Anionic and non-anionic.
So that...
A formulation, of course. It's not
okay.
a surfactant addition. It's a formulation based on combination of anionics and non-anionics together.
Okay, so starch can be removed. Huh? Starch can be removed.
Then starch is removed by other. It's
so the desizing agent means that sizing chemical to be removed. That's why it is.
That's a terminology which has been added. But the role of surfactant is primarily wetting agent. Starch, surfactant won't be able to remove.
So that's why I am curious that how that
is primarily a wetting role. And that is the reason why I have presented another table where surface activity and correlation with different stages of textile was presented. Another table. All terminologies that have been added together.
Okay. Thank you, sir.
So in interest of time, we need to wrap up the Q&A. I now invite Professor Deepti Devbakar and Shri Abhijit Achwal to hand over the memento as a token of appreciation to Honorable Vice Chancellor of Mumbai University, Professor Ravindra Kulkarni. Thank you. Please settle down. I would request Dr. Saptarshi Maithi to deliver the vote of thanks.
Respected dignitaries and eminent personalities present in the auditorium, my colleagues, students and friends, I thank you all for joining us this auspicious evening of 9th late Professor W.B. Achwal Endowment Oration 2025. First of all, I sincerely thank Professor Achwal's family members, especially his children, Mr. Abhijit Achwal, Professor Deepti Devbakar, Mrs. Swati Dewan, his son-in-law, Professor Dilip Devbakar, and Mr. Makran Diwan, other family members, and needless to mention Dr. Vijay Habbu for their continuous support and active participation to organize this event. We are very happy to have them with us on such an auspicious evening. The program would not have been initiated without their active cooperation and enthusiasm. I take the opportunity to thank the speaker of today's endowment oration, Professor R.D. Kulkarni, Honorable Vice Chancellor of the University of Mumbai, delivering an excellent lecture on advancements in surfactants for textile applications. He has clearly and lucidly explained the relevance of surfactants and its chemistry for the developments in the field of textile processing. He has also enlightened us on the scope of the advanced surfactants and their need in the textile arena. Thank you, sir, for your expert and fabulous talk on this theme. I am grateful to our in-charge Vice Chancellor and Dean IQA, Professor Ashwin Patwardhan, for his gracious presence among us. I would also like to thank our Registrar, Professor B.F. Jogi, whose invaluable support is always there for conducting any event at ICT. I take this opportunity to thank Professor Ashok R. Atle, the head of the Department of Fibres and Textile Processing Technology, for his enthusiasm, tireless efforts, and encouragement to his colleagues to make any program successful. Last but not the least, I honestly thank all the audience for their positive and enthusiastic presence throughout the program. Without your presence, no program can be successful. Thank you all. Stay safe and blessed.
Thank you, Maithi sir. I request everyone to kindly rise for the national anthem.
पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तब जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
I now invite all the dignitaries, well-wishers, this endowment organizing committee members and family members of Professor Achwal to the dais for a group photograph. Following this, I request everyone to proceed for high tea arranged outside. Students are requested to exit through the back gate. Thank you all for the gracious presence.